Greetings, everyone. Thank you for coming today. My name is Cho Wai-lun, and I'm excited to present my CTV final project, Ding Ding, a real-time Hong Kong tram simulator in Unity 6. The goal of So I will start with the introduction and then project objectives and the methodology and tools and pipeline prototype illustration, requirement analysis, implementation overview of challenge that I face, conclusion, what I learned, future work limitations and risks and references and the references. The goal of this project was to build an accurate real-time tram simulator that captures the unique character and engineering challenges of the Hong Kong trams. Key features include double bogie tracking system, procedural extrusion, adaptive camera mixing between cockpit, upper deck, and external views. A localized event manager with reactive AI precedence, and the final outcome successfully balances technical fidelity with smooth interactive performance. Hong Kong trams are special. They have a high center of mass, run on narrow 1027 mm gauge tracks and operate in very dense urban corridors. My simulator aims to preserve and let people experience these operational idiosyncrasies for both education and entertainment. The main objectives were develop a mathematical rail tracking engine that prevents derailment and correctly binds multiple edge splines, implement dynamic procedural mesh generation for rails so they can be executed in real time without mesh filtering. Create an immersive multi-decker experience with proper cockpit and upper deck perspective. Build a localized reactive AI system featuring event-driven jaywalkers and photographers who respond to tram signals and movements. The biggest technical challenge was Unity's rigid body physics. When I tried to use physics alone, I faced constant micro-stuttering, clipping, and derailments. My solution was a hybrid mathematical kinematic approach. I used parametric spline sampling to calculate precise position and rotation, while keeping rigid body only for stabilization and collision detection. This gave me deterministic, brutally smooth tram move. I used the following tools. Unity 6 core engine chosen for its excellent splice package and URP performance. Blender for mesh verification, pivot alignment, and asset preparation. C Sharp for all vehicle controllers and event architecture. And FEX as a universal bridge between Blender and Unity. I developed a clean cross-platform access pipeline that ensure consistent scaling and hierarchy between Blender and Unity 6. The tram itself features a classic dark green with cream livery, teak wood windows, destination board blinds, safety grills, and halogen high headlights. The tracks are accurate 1027 mm narrow garage groove rails integrated with realistic asphalt features and markings. I also modeled a typical Hong Kong tram stop with its curved canopy and roof signage. Instead of building hundreds of unique buildings, I choose I choose a tile-based modular system. This allowed me to create an expansive Hong Kong corridor with tall tenements, modern skyscrapers, popular marketing, and sidewalks, all while maintaining good performance. I based the simulation on real-world data, average operating speed of 50 to 30 kilometers per hour, high passenger density, and frequent passenger interaction, are very typical of Hong Kong tram routes. During development, I faced several significant challenges. I keep getting argument out of range, especially at the end of slides. The tram would flip 180 degrees or stop unnaturally. So I have replaced module indexing with MATCAM01 and add proper velocity clocking at terminals. Another challenge is that the tram will spawn off the rails and facing the wrong direction. So I've created a spline inversion utility to and carefully adjust y-axis snapping. Last but not least, the external rail mesh scale mismatch caused a global rescale that crashed the Unity editor and corrupt my recipe. So I have to rebuild the project and decouple visual rails from the mathematical splines and place modular visual segments on top of invisible splines. Despite these challenges, I successfully implemented stable dual bulky pieces with smooth development free motions, dynamic motions, dynamic camera switching between external cockpit and upper deck views, realistic braking, acoustic gain signal, and custom track behaviors. I moved from mesh collision physics to a fully deterministic kinematic system using Unity Splice API. I also developed a double bogey scaling system with proper heading vector correction and centrifugal rail based on dot product curvature calculations. So this is the game demo of my game. Greetings everyone and welcome to the demonstration of my Hong Kong tramway simulator, built entirely within the new Unity 6 engine. My objective for this project was to create a highly accurate physics-informed digital twin of Hong So Kong's greetings everyone and welcome to the demo automatic dynamic as you apply for as a game of is there some more there's another after make a stop. Okay. So we will soon arrive. Looking, this project taught me far more than just technical skills. I gained deep mastery of the Unity 6 Splice API, efficient animation triggering with animator, string to hash, and the importance of correct y-axis alignment vehicle simulation. More importantly, I learned that asset scaling, pipelines, and version control are just as critical as clean code. Resilience and good time management turn out to be essential. Looking ahead, I plan to reintegrate and polish the tram event management and jaywalking AI system, expand the map with more sectors, add temporary logging, and conduct proper user testing, may implement automatic backup policies. Time constraints mean I couldn't fully polish the AI behaviors. Large scenes transformations also make the editor occasionally fracture. The project may remain somewhat dependent on high quality external 3D assets. So these are the reference, and that's all for the presentation. Thank you.